Now we need to do some testing for the pump, and the testing will start from the manufacturing process. Then we're going to have a final testing for the pump after the assembly process. So once again, when you're going to do the casting, you need to inspect the part. It's actually very hard to do the instruction process for all the parts. You cannot create them all, but we got the samples from the foundry, and we're going to check the samples visually, check the surface roughness, check the quality of the casting. If all the cavities has been fully filled, this make it good. If not, we have a problem. Also, I can take some samples, send them to the lab if I don't have the facility to do that. In the lab, they will check about, for example, first checking if we're going to have the required strength by putting the part under the different compression test or vibration test. And this will tell you, okay, now the samples has been passed, so we can order the amount of the casted part from the foundry and start to use them. We take the part and we start to do the basic machining of them. Once again, we finalize the shape, geometry, and then we start to do some other inspection like the surface roughnesses, the dimensioning, and usually more testing you are going to make for the part, less faulty pumps you are going to have at the end. You are going to make this part, and you need to check the quality, check the surface roughnesses, check the internal surface roughnesses, check the dimensions. This is very important for both shafts. Same thing for the main body. You check the surface roughness for the internal bore, check the dimensions, the location of the dowel holes, the location of the drilled and tapped holes. All good? Then we start to do the final test for the part Y. Assemble the pump. Okay, now one of the tests is, now I assemble the pump, I start to move it. Now this one actually have some certain movement. I'm going to add the other pump and check. Now it's been reduced. I don't have any loose spot. Now the tolerances here is going to be very important. The diameter of the gears should be exactly almost little bit lower than the diameter of the bore we have here. Otherwise, it's going to be large. You're going to have loss in the pressure because the liquid is running backward. Second, we may have a vibration at a very high velocity, and this vibration may blow up the whole pump. So this will be one of the tests. I can see that the thing is moving by hand freely. It's had the minimum vibration done. The other test I can do is assemble the whole pump. Okay. Seal this side. Seal the outlet port. Just plug it. And I'm going to pressurize the pump by adding a pressure which is equal to twice the pressure that this pump must take. And then I'm going to keep this pressure constant, leave it for 24 hours. If the body of the pump can take this pressure, that means this is good quality. This can pass the test. The other test is assemble the full pump. By the way, the pressurized by water. Usually pressurized by water. Why? Because the water is a clean media. So even if something happened, I'm not going to have the whole place filled with oil. Water, we can dry it, and that's done. The last thing is I'm going to assemble the whole pump, and then I'm going to check the movement of the shaft. If it's all good, I'm going to attach it to the test motor. Keep it run for 10,000 hours. 10,000 hours. If the pump will work in 10,000 hours with no fail, that means it's passed the test. We call it the life test. Because usually all the equipment we have should have the lifespan of 10,000 hours. After that, even the cars, by the way, after that, if it's failed to run the test for 10,000 hours, that's mean my design is wrong, or the manufacturing process or the metal I use were wrong or the dimensions are wrong, and then I need to modify everything and start up with the beginning. So this will be the testing. Now, one of the examples we need to talk about is going to be the wasted material, because this will be very important. We're going to have out of wasted material, the minimum one is going to be due to the casting operation than the machining operation, because the layer I'm going to remove from here maybe it's going to be 3 or 4 millimeters. The same thing from here. Some material is going to be removed from the drilling and the tapping, which is not going to be too much, but the main metal loss is going to be by the machining of this part. We said that the original part here is going to be a cylindrical shape, a cylindrical bar, and if I would like to check the amount of the metal I lost from this operation, is I need to calculate the amount of the volume and the mass of the metal I lost. So I can do this one very simply. I know what the steel I made this shaft from, and I can find its density. Density is anything between 7,200 kilogram per cubic meter to 7,800 kilogram per cubic meter. And I need to find the volume. So how to find the volume of the original bar I have here? Simply the maximum length of this shaft, which is the addition of the 47, okay, plus the plus the 90 plus the 64, okay, so I have 90 plus 64, this will make it 154, plus 47, 164 plus 47, we're looking at 211 millimeters. So total length here is 212 millimeters. 212 millimeters. That means that the startup material again to start with is going to be at least 215 millimeters. 215 millimeters. The diameter, this one is 57, so the minimum diameter I should start with is going to be 60 millimeters. So I have a cylindrical shape, 215 millimeter length, and 60 millimeter diameter for the base. So I can find the volume, multiply this volume by the density, and I can find the mass of the original part. Now I got the weight of this one. I put it on the scale. This one is 1.577 kilograms. 1.577 kilograms. Subtracting the two masses, and I will find what will be the wasted material mass I had. Usually the wasted material is really to be recycled. By the end of the life of this pump, I can take these shafts, okay, I can either resize them to use them in another application, this will be the reusing, okay, or I can simply just melt them and make a new thing. Same thing for the main body, because the assembly process is going to be very easy for this one. One of the hardest things I'm going to have is to take off the cap. And taking this one is going to be easy. Take off the bushes is going to be a quite complicated process. It's required certain tools to do that. But I can recycle every part if I'm going to separate it from the others. The good thing that the number of the parts we have here is quite low. Few parts. Okay, so but all the chips I removed during the machining process is going to be a waste, because it's going to expose to a very high temperature. This will change the characteristics of the material, and also some of them is going to be, well, high temperature that's going to be mixed with the cooling fluid. It's going to retain in the basin of the milling machine or turning machine for a while, and this will actually going to generate an oxidation layer on them. So it's actually, we can say that all the chips we have due to the machining operations is going to be a waste material that we cannot recycle. Some people actually recycle this one, but we're not going to have a constant property for the material we're using, because different temperatures, different thicknesses, different oxidization. I saw some of the institution, for example, like the tapes, they've taken this chip and they use it to show the student on how to do the casting operation, because they don't worry about the property of the casting they're going to have. Okay, so just consider that the wasted material it's going to be actually wasted material. It's not recyclable. So the parts can be recycled, but the wasted material is gone. It's wasted material. Okay, so thank you. I think that's it for this session. We explained almost everything. The only thing we need to do is I need to do the weighing for the other 3 shafts that we had for the parts. I'll try to get the masses of the bodies as well, and this will help you do some basic calculation about the cost. Thank you for your listening, and hope to see you soon.